Hi, welcome to another edition of Fun with Conceptual Physics, the second law review edition. Put your name on this paper. I'm going to collect these for notes. You need to take all the notes I give you or you will not get full credit. Define Newton's second law. His second law was F equals mass times acceleration. Another version, which is quite popular, is F divided by m equals a. That version can tell us a lot. For example, if you look at the next question, if the force is tripled, underline those. So if you triple your force, your acceleration will triple because it's a direct relationship. On the other hand, if the force stays constant but the mass is tripled, what happens to acceleration? Well, if the mass triples, the acceleration decreases because it's an inverse relationship, and you have to think of the word reciprocal. So 3 divided by 1 is the same as 3. So if I put that here, 3 over 1 is the same as 3. So if I reciprocate 3 over 1, I get 1/3. What happens is, if force increases, so does acceleration. However, I'm going to have to squeeze this in over here. If mass increases, acceleration decreases because of the inverse relationship. Moving right along, giving you a second. If you're a heavy object, you're going to require always more force. It's got to get you going. You have more mass, it's harder to push you. So, over here, on this side, acceleration and net force, direct relationship. If force increases, acceleration increases. If force decreases, acceleration decreases. On the other hand, acceleration is an inverse relationship with mass. Let me highlight this a little better. This is an inverse relationship. If mass increases, acceleration decreases. If mass decreases, acceleration increases. Just remember, if you're a big mass, you're going to have a small acceleration. It's about that easy. For example, I'll pause. The next question says a cement truck and a moped. A moped is a small motorcycle. The mass of the cement truck is huge compared to the very small mass of the moped. Notice I did that. Who's going to require greater force? Well, the force of the cement truck is going to have to be bigger, since the mass of the the mass of the cement truck is huge. So you're going to need only a small force to stop the moped. Notice I've physically drawn the m's different sizes and the forces. So this cement truck is going to require a big force. There you go. Now, a bug is going to come into a windshield. So you got a little bug here flying along. And there's a car. And the bug's going to go into the windshield and hit it. They're going to have the same force, but think about it. Since the mass of the bug is small, and the mass of the car is big, the bug's going to have a big acceleration and the car is going to have a small acceleration. That bug is not going to move that car, but the car can move the bug. So once again, small mass means big acceleration. And big mass means small acceleration. Put an equals between these. We'll talk about this when we do Newton's third law. So if you have a big mass, you have a big force. If you have a big mass, you have a small acceleration. These next problems are pretty straightforward. Calculate the net force. What do you do with the arrows that go the opposite way? You subtract them. So the net force should be 1200 minus 800, which will be 400 newtons up, because the up arrow is bigger than the down arrow. Here, you have 800 minus 600. So that should be 200 newtons down. This is going to be a two-dimensional problem, so you need to use Pythagorean theorem. Oh, wait a minute. No, we won't. What is 50 minus 50? Why am I subtracting? Anyone? You, over there in the blue shirt. What did you say? A little louder. Yes. Clearer? Oh, because 50 up and 50 down will give you 0, so the net force is simply going to be the 20 newtons. There's no adding or subtracting with this. This is not a 2D problem. Don't get fooled. When you do get a two-dimensional problem, you do have to use Pythagorean theorem. Now, think about it. If I push with a big force like that, guess what direction my acceleration will be in? Yes, the same. So, the net force is always in the same direction as the acceleration. Net force, same direction as acceleration. That should make common sense. Flipping the paper over. What is the mass of 55 kilogram on the moon? On the moon. Well, gravity is 1.6 and weight is mass times gravity. So if you take 55 times 1.62, you'll get an answer. And the answer should be newtons because it is a force. We won't worry about the math. Anybody can multiply these numbers together. Right now I want you to understand that first, weight is this formula. Second, the units are newtons. That's the most important thing in this problem. Okay, calculate the force that a car will hit a tree if the car has a mass of 3,000 kilograms. This is the mass, this is the acceleration. Use F equals ma. You're going to do this on your own and give me an answer. And of course the unit should be newtons. What is the mass if the truck is accelerating? This is your acceleration, this is the force. If I flip the paper over, we have another version of this equation. F over A equals M. So show F over A, do those numbers, put the number up here, put the number down here, equals, and the units of mass will be kilograms. They want to find acceleration. You know the mass, you know the force, so F over M equals A. These next two, I'm going to let you do on your own, but you need to do those. Oh, wait a minute. This is a little different. You're pushing with a force, and friction is 5. So if you push with 20 and friction fights you with 5, what's your net force? Well, you're going to subtract those two, so get your net force in newtons, and then they want the acceleration. Well, F divided by mass will equal A, and the unit should be meters per second squared. Since I did this one, you can do that one. Remember, put units on your answer, units on all answers. Now, these people are pushing a washing machine. They push with 40 and sun's vertically. Uh-oh, this is a two-dimensional problem. As soon as you see the words horizontal and vertical, use this formula. F equals square root fx squared plus fy squared. This is going to be your fx. This will be your fy. Remember, square them, then add them, then square root them. Do not forget to square root. You should have some answer, and the units will be newtons. Now, once you get your answer, F divided by M should equal A, so your answer should be something meters per second squared. Weight is mass times gravity. Well, you're given the mass right here. The mass is 200 kilograms. Remember, G is 10 meters per second squared. Well, there you have it. You have about 10 minutes to finish the back side of this paper and then hand it in.